Professor, you were talking about the business, our IT projects are business changing process, and you've shown us a example which was a failure. Could you please tell us another example, another successful example? Which company, which organization has done well in this area, in this situation, and as a case study, something like that?
Well, I mean, the easy ones to pick are, of course, the ones that I have either been associated with or been following very closely. The company that I set up and no longer have any contact with, I set up a company called Praxis back in 1983. It's now forms the core of what is Altran UK, and they have just implemented the new air traffic control system for the United Kingdom, a system called IFACTS, which does 10-minute look ahead at the airspace. In order to be able, it does trajectory calculation and weather analysis for all the aircraft, knowing the wind speeds and the takeoff weight of the aircraft and what their clearances are and so on, in order to be able to predict where the bottlenecks are going to occur in the air traffic system, in order that they can help the controllers to provide medium-term clearances to aircraft that are conflict-free, where they're not going to have to take any action later on in order to keep aircraft separated. And by doing that, they're able to get much more traffic density through UK airspace without, in any sense, compromising safety. And that's in place now, and it's been running for a year or more. And National Air Traffic Services say that it has increased the capacity of airspace significantly. And if you look on the NAT's website, you'll find details of that. Now, that was a computer system which was specified using a mathematically formal specification language. The required properties were then proved against the specification to show that the system, if built according to the specification, would actually do what it was expected to do. It was then implemented in a language which has mathematically formal meaning to the programming language statements, so that there is a tool set which could actually prove two things about the software that was written. Firstly, that it genuinely did implement the specification and nothing else. And secondly, that under no circumstances, under no input conditions, could it crash. Could it actually overflow a buffer and overwrite itself, or lose control of memory and run out of memory the way that the London ambulance system did. Or have a fixed point overflow where you're trying to put a number into a field that's too big for the field that it goes into, and so on. None of those things can happen. They have been proved not to happen. And the system it's 250,000 lines of code. It generated 750,000 mathematical proofs that had to be proved in order to be able to carry out, to show that the whole system proof was correct. But that 250,000 proofs can be repeated following a change in 15 minutes on a desktop computer. So it's a coffee time activity to reprove the system. You can make a change, revalidate the system while you go and get a cup of coffee, come back, and it's either found a bug that you've introduced or it's shown that it works. So those sorts of systems are successful because they're being built by engineers using engineering methods. Most IT, as we've discussed a couple of times already, is not being built by people who are following any real engineering disciplines or using any rigorous methods that enable them to make strong statements about their systems. And the company I'm talking about, Altran, gives warranties for its system. It provides guarantees. None of the small print that says if it goes wrong, it's your fault. They write guarantees and they fix any bugs free.